Today we're going to work with exponents and just review that and make sure that we have all the kinks worked out and understand that. So what an exponent is, an exponent tells how many times the base is multiplied by itself. So when we look at an example, this is what they look like. So 5, in this example, 5 is our base and 4 is our exponent. So the exponent 4 tells us that the base 5 needs to be multiplied by itself 4 times. So what that means is 5 to the 4th power, and that's how we would read this. 5 to the 4th power means 5 times 5 times 5 times 5. We multiplied 5 by itself 4 times. We used it 4 times as a factor. Now, it means, again, 5 multiplied 4 times by itself. What it doesn't mean is 5 times 4, but that's the most common thing people do wrong with this. And when we work it out, 5 times 4 is 20, but if we work this one out, 5 times 5 is 25, 5 times 5 is 25, 25 times 25 is 625. So it is surely a far cry from being equal to 20. So we have to make sure that we actually write it out and actually do the multiplication. Now there's a little bit more vocabulary that needs to go along with this. Some vocabulary we would hear associated with exponents is the word squared. When a number is raised to the 2nd power, we could read that as being squared. So our example up here, we could read as 4 to the 2nd power, but we could also read that as 4 squared. And that's because if you multiply 4 by 4, that's like having a 4 by 4 square. We could also say cubed, and when we say cubed, we're referring to a number that is raised to the 3rd power. So when our exponent is 3. So for example, we could read this one as 7 to the 3rd power. We could also read it as 7 cubed. And the reason it's called cubed is because if you think 7 times 7 times 7, if we have a cube that is, if we have a three-dimensional figure rather, that is 7 by 7 by 7, that could be a cube. That's why it's called cubed. Then the next piece of vocabulary we need to know is exponential form. Exponential form means we take a multiplication problem and we rewrite it using a base and an exponent. So in our examples here, 4 times 4 times 4 times 4 times 4. We could rewrite this with a base of 4 because 4 is what's being multiplied, and it's 4 to the 5th power. 1, 2, 3, 4, 5, because 5 is being multiplied by itself, or 4 rather is being multiplied by itself 5 times. The next one is an example of 7 cubed. 7 is being multiplied by itself 1, 2, 3 times. And it doesn't just have to be whole numbers that we're talking about. It could be fractions, it could be negative numbers, which are of course whole numbers, but they could be whole numbers, but it can also be even variables. R times R times R times R. R is used as a factor 4 times, being multiplied by itself. And we can even write something like this last example using exponential notation. Now we can't just write one base and one exponent because we have 2 different numbers that are being multiplied. What we can do though is we can say, well, this part right here means 3 times 3 times 3 times 3. 3 is multiplied by itself 4 times, and this means 8 is multiplied by itself 3 times. And then we put a multiplication symbol between those because that's what's in between those 2 sets of factors. So this one could be rewritten as 3 to the 4th power times 8 cubed. Now, when we get to looking at this a little bit further, we can look at expanded form is when we write it out as the multiplication. Exponential form, of course, is when we write it with a base and an exponent. We can also evaluate it. That means find the value of it by actually multiplying it out to find the product. So take a moment to see if you could fill out this chart and then pause while you do it and then check your work. All right, now that you've done it, you should have said 2 times 2 times 2 means 2 cubed, or 2 to the 3rd power. The product is 8 because 2 times 2 is 4 times 2 is 8. 2 to the 5th power, if we write it in expanded form, is 2 times 2 times 2 times 2 times 2. And if we multiply that out, we're going to get 2 times 2 is 4. 2 times 2 is 4. And then we have another 2 used as a factor. 4 times 4 is 16 times 2 is 32 as a product. For our next one, A is our base because it's what's being multiplied repeatedly. 1, 2, 3, 4, 5, 6, 7 times it's used as a factor. This one's a little different. We can't actually find the product for this one unless we knew what A was. So for this one, the product depends on the value of A. If we knew, for example, that A equaled 4, then we would do 4 times 4 times 4 times 4 times 4 times 4 times 4. If A was 9, then we would do 9 times 9 times 9 times 9 times 9 times 9 times 9. We would just plug in and use that number if we knew what A was. But we don't, so we can only say the value of A to the 7th power depends on the value of A. All right, this last one, 6 times 6 times 8 times 8 times 8 times 8. We could rewrite as 6 squared times 8 to the 4th. And if we actually worked all that out, if you did your multiplication correctly, you get 147,456. So what you notice about this is it really, 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 when we use exponents, even though that looks like a simple problem, it can get to be a very big number very, very quickly. Now, some important things to note, any number that is raised to the first power is equal to the number. So, for example, 5 to the first power is equal to 5. 17 to the first power is equal to 17. Any number that is raised to the 0 power equals not 0, which is what most people would guess, but it equals 1. So 3 to the 0 power is 1, and 192 to the 0 power is also 1. Now, you're probably thinking, she's got to be wrong. That can't possibly be true. But it is, and let's take a look at why. If we look at it, let's think about this. We're going to kind of work backwards and think a little bit about some number theory here. We know 5 to the 4th power means 5 times 5 times 5 times 5. So 5 used as a factor 4 times, and that equals 625. Now, if we took the answer to 625 and we divided it by the base, which is 5, then what we're going to get is 125. Now notice, if we were to work out 5 to the 3rd power, 5 times 5 times 5, we get 125, which again is our 625 divided by 5. So in other words, 5 to the 4th power divided by 5 is equal to 5 to the 3rd power. Now we can continue that by saying 5 squared, we know, is 5 times 5, which is 25. If we took 5 to the 3rd power, which is 125, and we divided it by the base of 5, notice what we get. We get 25. So in other words, we get 5 squared. So 5 to the 3rd power divided by 5 is 5 squared. Taking it a step further, 5 to the 1st power we know is equal to 5. And if we think about it, that's really 25, which is the value of 5 squared, divided by 5, the base, gives us the value of 5 to the 1st power. So what you should be hopefully noticing from this is anytime I would take a number that was in exponential form and I divided it by the base, I should get what the next power down is. In other words, 5 to the 4th power divided by 5 is equal to 5 to the 3rd power because that's one lower power than what the 4 was. So thinking about that, what that means is 5 to the 0 power has to equal 1 because 5 to the 1st power is 5, and when we divide that by 5, 5 divided by 5 is 1, not 0. So that would work for any number. You could plug in any number that you wanted to try this with, and it's always going to work out that the number to the 0 power has to equal 1. So let's do a couple of examples, see if you get these. Take a moment to try them, and then see if you've gotten them correct, and then we'll check them. All right, so if we want to look at the values, 2 to the 5th power, we've actually already done this one, but again, it means 2 times 2 times 2 times 2 times 2. 2 times 2 is 4, 2 times 2 is 4, and then another times 2. 4 times 4 is 16, times 2 is 32. M cubed if m equals 5. Now this one's a little different because we actually know that m is equal to 5. So if we want to do m times m times m, that means we can do 5 times 5 times 5, which is 125. And then last but not least, 3 to the 4th power means 3 times 3 times 3 times 3. 3 times 3 is 9. 3 times 3 is 9. 9 times 9 is 81. So 3 to the 4th power is 81. All right, try these on your own and then check them and see if you did them correctly. All right, if you have done those correctly, these are the answers you should have gotten. Congratulations if you got those all right. You're well on your way to understanding exponents. Now let's say we want to take it just a little deeper. If we want to take it a little deeper, we can continue looking at negative exponents. A negative exponent is when you have a base with a negative exponent, it's always going to equal 1 over whatever the base with a positive exponent would be. In other words, the reciprocal of whatever the base with the positive exponent would be. So for example, 4 to the negative second power is actually equal to 1 over 4 to the second power. So that's 1 over 4 times 4, which is 1/16. 6 to the negative third power is equal to 1 over 6 cubed. So 1 over 6 cubed means 1 over 6 times 6 times 6, which is going to be 1 over 216. And last but not least, 5 to the negative first power is going to be equal to 1 over 5 to the first power, or 1 over 5. Now, why, you ask, is that true? Well, let's go back to what we talked about before, where we went this far, and let's continue our logic. If we wanted to do 5 to the negative first power, so we're going down one more power. Every time you go down a power, remember what that means. Remember, it means you're taking the value of the power above it, and you're dividing it by the base. So in other words, 5 to the negative first power has to be 1/5, because if you take the value of 5 to the 0 power, 5 to the 0 power is 1, and 1 divided by 5 is 1/5. 5 to the negative second power is 1/25, because if we took 5 to the negative first power, which is 1/5, and we divided that by 5, we're going to get 1/25. That's why our negative exponents give us unit fractions, fractions that have 1 as a numerator and then another number as a denominator. Taking it even a little bit further, we can add roots. Roots are kind of like the opposite of exponents. It means instead of multiplying up, you are dividing by the same factor over and over. So a root is one of the equal factors of a number. So for example, and usually we see square root symbols looking more like this. I couldn't type it so that it had that line over top of it. But if it looks like that, that means the square root of 25. And what that means is what number squared equals 25. And a lot of this just comes down to memorization. So what number times itself equals 25? Well, that number is 5. And it's 5 because 5 times 5 equals 25. That's why the square root is 5. So then if we're looking for the square root of 4, that means what number times itself equals 4? And that's going to be 2. The square root of 49. What number times itself equals 49? 7. Now, we call 25, 4, and 49, they are what are called perfect squares, because a perfect square, it would be a number that has a whole number root. For example, 1 has a square root of 1. 4 has a square root of 4. 9 has a square root of 3. Or, sorry, 4 has a square root of 2. Sorry, 9 has a square root of 3. 16 has a square root of 4. And we could keep going on and on. 100, for example, is a perfect square because it has a square root of 10. So we talk about perfect squares as whole numbers that or they would be numbers rather that have a whole number root. If I think about a number like 48, for example, 48 does not have a whole number as a square root, because you can't do any whole number times itself, any whole number times itself, and get 48. Now there are other roots as well. We call this first example here would be finding the cubic root of 64. Notice we have that 3 right there. That means we're looking for what number to the third power equals 64. Again, some of this really comes down to memorization. So the cubic root of 64 is going to be 4. And the reason is because 4 times 4 times 4. 4 multiplied by itself 3 times is 64. The cubic root of 27 is going to be 3. 3 times 3 times 3 is 27. The square root of 16, now I could put a 2 here, but generally you don't see it written like that. It's just understood that if it's a square root symbol and there's no number there, that it means you're looking for the square root, or if it's a root symbol with no number there, that you're looking for the square root. What number to the second power? The square root of 16 is 4. And interestingly enough, 16 is also a number where we can find the fourth root. The fourth root of 16 is 2, because 2 times 2 times 2 times 2 is 16. All right, now give this a shot and see if you can figure out what all of these are equal to. Take a moment to pause. I'm even going to give you a little bit of extra help on this one. I'm going to give you an answer bank. Take a minute, pause, and try them, then check your answers and see if you were on the right track. All right, now that you've had a chance to do them, check and see if you've got these right. Now, if you've gotten these right, you are pretty well on your way to understanding all about exponents and roots. Excellent job.